Hello friends, this is a whole new topic that we are going to start today. We are going to start about a part of VLSI which is called the MOS amplifier part. Okay, so we are going to talk about the MOS amplifier and how the MOSFET can be used to work as an amplifier. Let us first start with a basic diagram how the MOS can work as an amplifier. The basic diagram is that first we have to give a voltage source out there and a MOSFET like this. Okay, we have to connect it like this, and here we have to provide first of all a bias voltage surely, and we also have to provide the voltage that we need to be amplified, that is an AC voltage, because the DC voltage cannot be amplified like that. So this is the first requirement, and we have to take the output from here, right? So we first need to find out that in which region the MOSFET can work as an amplifier or not. So as we know from the output characteristics curve, the output characteristic curve that we know, that is of VDS versus IDS. The curve is something like this. Right, you can see these are the curves. Now if I put this MOSFET in this circuit with this resistance R, we know that we'll get a load line, and the load line would be like this, because VDS we can say here VDS would be equal to my VDD minus my ID RD, right? This is the part, this is the part that gives this negative slope. We know this, which is called the load line. So now let's start with this thing, that if we try to draw a thing which is known as the voltage transfer curve. What is the voltage transfer curve? The voltage transfer curve gives us the input to output voltages. Okay, if this is my input voltage, which is given as VGS surely, and this is my output voltage, which we get as my VDS, right? So what happens, suppose we know that what are these curves coming for increasing value of VGS, right? So as when VGS is very low, we can see that VDS is a quite high value. As my VGS increases, the VDS values slowly decrease, right? In this region, okay, the decrease in the cutoff region is quite less. In this region the decrease is quite high, okay, is quite high. Now if I draw one or two more curves in this region, we can see that here also the drop is quite less. So here we can find a quite big drop, and then the drop is again quite less, until it goes to almost zero value. Okay, so this is called the voltage transfer curve, or the VTC, that comes due to several values, like this is the A, B, C, D, E, F, G, H and I points. Here we get my A, B, C, D, E, F, my G, H and I points. Okay, so this gives me the voltage control curve, voltage transfer curve. This region is for which region? Is for this region, which is my cutoff region. This part, as we can see, is for this part, which is my triode region, and the middle part, this is for the saturation region, as we can see. So this is for the saturation. In which region should a MOSFET be used as an amplifier? We should definitely use the MOSFET as an amplifier in a region where the input to output voltage slope is quite high, as we know, as we have done for the BJTs. So in this region we should use the MOSFET as an amplifier. So we get this theory that MOSFET works as an amplifier in the saturation region. I'm sorry for my handwriting. Right. So this is a point that we should all remember. Okay. So in this video we explained how the MOSFET can work as a amplifier in the saturation region. That is, in the saturation region, what do we have to do? We have to make VDS should be greater than equal to VGS minus VTH. This is the condition that should be satisfied for the MOS to work as an amplifier. Thank you.